All right, so on the back of this exponential equations packet, the ones we're going to do today are going to be slightly more difficult, but using that chart is going to help. So on the ones we did on Friday, all of the ones we would only have to change one side of the equation and the other side would stay the same. On pretty much all of these today, we're going to have to change both sides. And so on 11, we have 125 to the y equals 25. And so we want to write 125 and 25 with the same base. And like I said, we're going to have to change both of those numbers. So what I want you guys to do is look at your chart. And what you're looking for is 25 and 125 in the same row. Do you guys see that? 25 and 125 in the same row? Yeah, so right here. So that means the base that we're going to use is going to be 5. And for 125, we're going to write it as 5 to the third power. And then for 25, we're going to write it as 5 to the second power. All right, so it's really the main difference today is just going to be a little bit more difficult at the beginning. So here we go. So for 125, like we just said, that is the same as 5 to the third. Now, what do you think we do with the old exponent? And then not add, we're going to multiply. So you're going to multiply the new exponent by the old exponent. All right, and then for 25, it's going to be 5 to the second power. All right, and then as soon as you have them with the same base, you can set the exponents equal. So we can go ahead and drop off the 5s and say that it's 3y equal to 2. And then to solve it, we would just divide by the 3. Now, you can see in my answers on the board, I'm leaving them all as fractions. It's up to you. If you would rather type that in the calculator and get a decimal, that's fine. I just think it's just as easy to leave it as a fraction. So that's it. Now, they're going to get a little bit more difficult than that, but the main new thing is we have to change both sides. All right, so let's just go ahead and do number 12. So for number 12, we have a 16 and we have an 8 that we want to write with the same base. So I'm going to scroll. I wish I had a little bit different order. Okay. So we're looking for 16 and 8 in the same row. And so when I look, I can see 16 and 8 are here, which means the base is going to be 2. And it means that 8 is going to be 2 to the third, and 16 is going to be 2 to the fourth. All right. So for 16, we'll do 2 to the fourth, and then we're going to multiply our new exponent by our old exponent. All right, 8 is going to be 2 to the third, and then same thing. Multiply the new exponent by the old. Okay. So now I can drop off the bases. I'm going to go ahead and multiply at the same time. So 4 times 3x is 12x. And then we have to be real careful on the right side that you distribute that 3. All right, and then we just want to solve this for x. All right, and then that reduces to 2/3. So you can give your answer as 2/3, or you can give your answer as 0.66666. Right. Okay. Now, one thing you're not going to see in the table are fractions. So let's skip down and do number 14. Like 1/3, you're not going to find it on the chart, but you will find 3 on the chart. So we still have to remember some things from Friday and earlier in the year. So we're on the chart, we're looking for 3 and 81 in the same column. All right, and here it is. We have 3 and we have 81. So we're going to rewrite 81 as 3 to the 4th. So it would be 3 to the 4th, and we multiply our new exponent by our old exponent. Good. So 3 to the negative 1 is 1/3. So I can rewrite 1/3 as 3 to the negative 1. And then, like he said, we're going to multiply our new exponent by our old exponent. All right. So then, same thing. Drop off the 3's and distribute that 4. Now, most of the time I try to like work it out so my x's are positive. We can't do that this time. Or if we did, it would be like a wasted time. So because I only have x's over here, it's smarter just to move my x's to that side, which means you are going to have negative x's, but that's okay. So we have that 20 is equal to negative 10x. So x is going to be negative 2. Trying to decide which one to do next. Let's just do 16. All right, so we're going to look at the chart and we're going to try and find 27 and 243 in the same row.
What number again?
16, sorry.
3.
Yeah, in the row for 3. So 27 we can write as 3 to the 3rd, and 243 we can write as 3 to the 5th. All right, and then don't forget, we're multiplying our new exponent by our old exponent. Okay, and then we just drop them off and do our multiplication, being careful that on the right we're distributing. Oh, this one ends up being kind of nice. When we move our x's together, we have our answer. Okay. So now these 4 at the bottom, they take like what we just did and just make it just a little bit more difficult. So let's just do 18. So whenever we are multiplying and there's the same base, what do we do with those exponents? Do you remember? You're going to add. So the 9 is not going to change. It's going to stay 9. But then we're going to add 2x and 2x, which is 4x. And then the 4 doesn't have any like terms, so it just comes over. All right. And then we want to write 1 over 81 is 9 to some power. Any ideas? Not 2, but you're close. So 9 to the second is 81. So 9 to what power is going to be 1 over 81? -2. Very good. Very good. Teamwork. Okay. So then we'll set these equal. All right, and we're going to get another fraction, but that's okay. All right. So what questions do you guys have? I'm gonna do one more. I'm gonna do this 20 because it's got everything.
What's your for
18. I got -3 halves or -1.5, either one. So now what you got?
I forgot to put -2.
Gotcha. Okay. On 20, there's more than one way to do this because if you look at your table for 4 and 16, 4 and 16 are both in two different rows. So 4 and 16 are both here, where we can write them with a 2, but 4 and 16 are both here also. In this problem, if you do it right, it'll be perfect either way. It's going to be easier if we just use the 4 and the 16. We won't have to change as much. So that's what I would do if I was you. I would rewrite. I would leave the 4s like they are, and I would rewrite 1 over 16 as 4 to the -2, just like what we did with 1 over 81. All right, then I'm ready to go ahead and add those because they both have a base of 4. Right. And as soon as it's just 4 to something equals 4 to something, we can drop off the 4s and then just solve it from here. Bless you. All right. So what I want y'all to do, and be sure if you get stuck or you're confused or you don't get the answers that are up there, just let me know. But on the very, very back of the packet, the back of Unit 7, Homework 2, just do the back side. And then this will be the last day we use this packet, so you can turn it in when you're done.